Welcome to the next module. In this module, we will be studying about biogeochemical cycle and Arctic Part 2. So the main focus of this module is chemical reactions. So we will be studying about acid-base reactions, precipitation and dissolution of minerals, sorption and ion exchange, oxidation reduction reactions, biodegradation, dissolution and exsolution of gases. Let us look at the major reactions related to important solutes. The major anions are bicarbonate and sulfates. The use of protons for the chemical erosion of glacial sediments include sulfide oxidation and dissociation of atmospheric CO2. These are all the two main sources of H+ ions. Solute contribution from the seasonal snowpack are limited to the early melt season, accompanied by transient weathering of crustal material associated with snowpack acidity. Let us look at an important reaction, which is the Urey reactions. Urey proposed that atmospheric CO2 combines with calcium silicate to generate calcium carbonate and silica. That is atmosphere, land, ocean. All the three are involved in this. Calcium silicate plus bicarbonate gives calcium carbonate and silica or silicon dioxide. The carbonation takes place when atmospheric CO2 forms carbonic acid in rain and snow melt. So this happens in the atmosphere, ocean, that is water area, which provides the proton for silicate mineral dissolution, that is wolfsonite, to give calcium, bicarbonate and silica. So this happens in the land. The resulting calcium and bicarbonate ions flow in reverse to the ocean, where either organic or inorganic precipitation produces the calcium carbonate. Part of it may be locked into biogenically deposited carbonate on the seafloor. The chemical reactions are given here. The first one is calcium silicate reacts with carbon dioxide and water to give calcium 2+ ions and bicarbonate anions and SiO2, which leads to formation of calcium carbonate, water, carbon dioxide and silica. So the color difference talks about where the reaction actually happens. The dissolution of CO2 happens in the atmosphere water areas. The green color represents the land one and the last one is in the sea. Let us look at solute provenance models. So what do you mean by provenance? Provenance means the place of origin or sources. This is related to solutes. So from where the ions which are involved in the entire process are originating. That is what we are going to see. The solute derived from the marine source as sea salts transported by weather system to the catchment area. That is one thing. From aerosols as dry or wet deposition. These are all the sources of solutes. From the atmosphere due to sequestration of gases, from a crustal source as a consequence of solid solution interaction, complexity of flow patterns, ion exchange kinetics at the water-solid interface, buffering of pH, non-conservatism of solutes, and post-mixing particle-particle reactions such as carbonation reactions owing to englacial supply of dissolved bicarbonate. So these are all the sources of bicarbonate ions in the Arctic ecosystem. And when we look at the inorganic chemical reactions, the dominant subglacial reaction generating bicarbonate, that is in the aqueous medium, is carbonation of feldspar surfaces as given by the reaction. So feldspar reacts with carbon dioxide and water to give Ca2+ ion, bicarbonate ion and aluminosilicates. The hydrolysis of feldspar is given by this particular reaction. The feldspar is reacted with water, that is hydrolysis takes place to produce calcium +2 ions, hydroxide anions and hydrosilicic salts. Then hydrolysis of pyroxene also is given here. Calcium magnesium silicates reacts with water to give calcium 2+ ions, magnesium 2+ ions and hydroxide anions and hydrosilicic acid. So when we look at organic origins of solutes, the organic provenance characterizes solute derived from decomposed biota and microbial activity, that is carbon plus oxygen gives carbon dioxide. Bacteria may deplete oxygen levels and reduce nitrate and sulfate in isolated subglacial waters, leading to an aerobic environment, that is loss of oxygen. So that leads to aerobic environment. The release of CO2 will affect the carbon cycle and donate protons which are consumed in weathering processes. Let us look at the another source, that is geothermal source. The geothermal source has two phase components, an aqueous solution and degassing, that is gaseous component. The geothermal water input is probably negligible during the melt season, but it is a main contributor of solutes to subglacially stored water and winter runoff during accumulation season. CO2 and oxygen degassing could contribute to carbonation and oxidation reactions in the subglacial environment. So they are very crucial at that time only.